Hello, welcome back to our little corner on the web, where we hope to encourage the joy of learning. Today, we will discuss question 19 on part 1 of the recently concluded 26th Philippine Math Olympiad area stage. Again, thank you to the organizers for sharing the questions. Question 19 states that Himmel has a watch with two hands, a minute hand and an hour hand. Starting at 12 p.m., he ran 3 laps around a long oval track at a constant rate and finished before 1 p.m. After every full lap, he recorded the distance between the tips of the two hands on his watch. In the order that they were recorded, these lengths were 11 millimeters, 16 millimeters, and 17 millimeters. The minute hand is longer than the hour hand by square root of c millimeters, where c is a positive integer. What is the value of c? Okay, the first thing we notice here is that the rate is constant. So given that the rate is constant, the growth of the angular displacement between the clock hands are also constant. What do we mean by this? So let's look at an example. Here in our example, every clock image here, 15 minutes has elapsed. So the angular displacement, if we let the angular displacement at 12:15 be theta, we know that from an angular perspective, the minute hand travels twice as much if we now go to 12:30. And the same thing for the R hand. So the theta will grow from theta to 2 theta when it goes from 12:15 to 12:30, and will grow to 3 theta when it goes from 12:30 to 12:45. So as we can see, that the angular displacement here is basically doubling and tripling as we go along. So we can take advantage of that relationship and use the law of cosines to relate the different unknowns that we have here. Just as a reminder, law of cosines basically states that the square of one side of a triangle plus the square of the other side of the triangle minus twice the product of those two sides times the cosine of the included angle is the square of the third side. So let's dive in. So after the first lap, we can express the relationship as the square of the hour hand, if we let the hour hand be h, plus the square of the minute hand minus twice the hour hand times the minute hand times the cosine theta, which is the cosine of the included angle, which should be equal now to the distance of the square of the distance of the tips, which is 11 squared. So doing some manipulation, we notice that 2h squared plus 2h times the square root of c is actually factorable on the left-hand side. So we can move this c, we can transpose this c to the right-hand side, and we have a neatly factorable equation. So just to make it more easier to follow later, we will write it as cosine minus 1 instead of 1 minus cosine. So we multiply -1 to both sides. Okay. Doing the exact same manipulation after the second lap, we have a very similar expression. As you can see, there's nothing that we did in the manipulation of the first lap to say that cosine theta was special. So technically, we could just have written the last line here immediately after we figured out the expression for the first lap. Okay, but it's exactly the same thing. The square of the hour hand plus the square of the minute hand minus twice hour hand, minute hand, cosine 2 theta. Okay. So if you've noticed that, the third one should also be easy because it's the exact same expression except for the argument of the cosine and the square of the distance between the minute and the hour hand. Okay, so now we really have 3 very similar looking equations. So it's just a matter now of manipulating them or combining them to get to what C is. Okay, so here, what we'll do is we'll use a couple of trig identities. Now you can also derive these trig identities. So we'll use cosine 2 theta is equals to 2 cosine squared theta minus 1. And cosine 3 theta is 4 cosine cubed theta minus 3 cosine theta. Again, if you don't remember it, you can derive this using the sum of cosines, right? It's cosine alpha plus beta. Okay, so rewriting the three equations just in terms of cosine theta, the first equation remains the same. The second equation now is quantity 2h squared plus 2h root c times the quantity 2 cosine squared theta minus 2 is equal to c minus 256. And the third equation is 2h squared plus 2h root c times quantity 4 cosine cubed theta minus cosine theta minus 1 equals to c minus 289. So some of you might already notice, if we factor out the 2 in the second equation, this is basically the difference of two squares, which is factorable by cosine theta minus 1. So doing a bit of substitution to make it easier to follow, we let y be equal to cosine theta, and then we can combine equations 1 and 2 and equations 2 and 3, 1 and 3 by division. Okay, so dividing the second equation here by the first equation, we end up with a simple quotient on the left-hand side, which is really 2 times y plus 1, which is now equal to c minus 256 over c minus 121. And combining equation 3 and equation 1 again through division, you will actually end up with just a very simple expression as well, the square of the quantity of 2y plus 1. Okay? So now we're just looking for c, so we can actually equate 2y plus 1 or 2y plus 2, depending on what you want. Here we equated 2y plus 1. So we ended up with the expression on the first equation here, minus 1, is equal to the square root of the right-hand side of equation 2. Again, just some simple manipulation, squaring them, combining them and squaring them. We end up with this, it seems to be from Simon's favorite factoring trick, but it's basically a quadratic. Okay. So now we can either use the quadratic formula, but as you can probably notice here, the numbers gets pretty big. So the question is, do we use the quadratic formula, which is actually an okay thing to do? It might just be a little cumbersome, or is there a faster way? Is there something that we can notice that will make solving this thing faster? Okay. So first thing to note, we're looking for two products of 135 squared that's 168 apart. Okay. If you notice, 135 squared only has prime factors of 3s and 5s. So we can actually play around with the factors of 135 squared and see how we can split them to find two factors that are 168 apart. Okay. So we also notice that if they're 168 apart, the 5 squared factor of 135 squared must be together. Okay. So if they have to be together, there's very few splits. There's actually 7 splits only of the two factors that's possible. So we can just play around with them and see if we can find one. So here I just split 3 cube and 3 cube on different sides. It doesn't quite work. The gap is too big. So I wanted to make one of them smaller, one of them bigger. So I moved the 3. It's still now, it's a little small, right? Smaller than what we want. And I shifted one more, and sure enough, we found that the two factors could be 3 times 5 squared and 3 to the 5th. So what that means is we have two possibilities. One is they're both positive, or they're both negative. So we can express those two equations simply as c minus 289 is equal to 75, or c minus 121 is equals to 243. That's when they're both positive, or when they're both negative, right? Which is now the second set of equations here. So we will find that there's two possible values for C. C might be 364 or 46. Now the question you might ask is, so which one is correct? Well, to find which one of these two will actually work, we go back to one of the original equations we have for law of cosines. It doesn't matter which one you pick out of the three that we initially came up with. We can dive in and see what the properties of the left-hand side is first to see what should be on the right-hand side. What we notice is h squared must be positive. And the R hand and the minute hand are also both positive, and we know that it's greater than by root C, and root C is a positive integer. So the first parentheses here should give us a value that's always positive. Okay. Cosine, we also know, should be from -1 to 1. In this case, it should be from strictly in between -1 and 1, which means that this second parenthesis should give us a value which is negative. That leads us to the statement that the right-hand side here must be negative. And of the two values, 364 and 46, the only one that satisfies for the right-hand side to be negative is C equals 46. Hence, C46 is the only solution. We hope that you found this video helpful and educational. If you did, do hit the like button and subscribe. Thank you for watching.